Hi, Miles Mathis. We read your recent article about the SAT question that everybody supposedly got wrong, um, and got into the SAT question, and we have a few different answers for what the right answer could be, and thought we'd share our explanation with you. So here we have two circles. They aren't exactly one 3 times the diameter of the other, but it is about 3 times. There's 1, 2, 3. It's a little bit, this one's a little bit too small, but it works well enough for the explanation. So what I think we can all agree on is that each point on the edge of the small circle will touch the edge of the large circle 3 times as it goes around, because the distance around is 3 times the distance around this one, right? So it just depends upon how you rotate it around. So how many times this one will flip. If you rotate it on its edge, I don't know if we can see, this is our marker of how, when it goes around once. So this is pointing down. If we go around, it's pointing down again here. Go around, it's pointing down again, here? And we go around, and it's pointing down again here, which is as close as we're going to get, since it's not exactly 3 times the diameter. So that one, the circle flipped over exactly 3 times. But if we have it flat in the same plane as the other circle on the outside, which is what I imagined first, it points up there, and we rotate it around. Our little marker points up there, but only gets once around in relation to this circle once there. Up here, it's pointing up again, but doesn't go 2 rotations in relation to this circle until here. This is pointing in here. It goes around. Did I miss one?
It was pointing up, yeah, right.
I missed
there.
one. Okay. Let's start that part over again. Okay, so it's pointing up once, or there's once up again, twice up, 3 times up, and 4 times up, as close as we're going to get to the starting point, due to the not exactly 3 times the diameter. So it actually this one rotated around 4 times, even though each point on it only touched this circle 3 times. So, you can see that from watching it rotate. The other way that we thought of this was it clearly rotates around 3 times as it touches each point on there, and then once, just because it's going to have this point touching the inner circle here, 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 and then back to here. And just in showing you that I rotated around the circle 1 more time. So that's 4th rotation. The other way you could think of it is if you could lay this purple circle out to the side, rotate this around its 3 times to get to the other end, and then curve it back to make the circle. That's your 4th rotation. As you curve the circle around, it makes a 4th rotation. We also noted that if you rotate it around the inside, now this inside circle is too small, you have to rotate around the outside circle again. We have kind of the opposite effect, where we rotate around, and at this point the outside of this circle has gone around the outside of the purple circle once, but it hasn't actually flipped over yet. It doesn't flip completely over until around the top. So that's 1 full rotation of the blue circle. And then at this point, each point on the blue circle has touched the purple circle twice, but it has not flipped over a second time, not until it gets down to the bottom. So if it rotates around the inside of the circle, it only rotates twice, even though each point on the outside touches the purple circle 3 times. So you have 2 rotations, 3 rotations, or 4 rotations, depending upon how you picture the question. So maybe anybody who wanted to answer 2, 3, or 4 was right if they were picturing the appropriate question. That's our explanation of how there are different possible answers. I had come up with 4 when I was asked the question, which wasn't an option. Okay, thanks. Bye.